So far, we've been focusing on issues with video when the video is actually playing, frame rates, fields, etc. Now we'd like to move on to some issues you can see even when the video is not playing. As I mentioned before, the computer world and the video world are different, and here's where it gets really, really obvious. Now here I have two monitors. One is a normal RGB monitor hooked up to my computer, and another is actually a video monitor, in this case an NTSC spec video monitor. We really recommend working with one of these on your system as well, so you can see the differences between the two worlds. Now, different video cards give you different options for this NTSC output. Some only show on that screen when they're playing video. Some can mirror part of the screen as a duplicate out to your NTSC screen. Other cards will allow you to actually have two entirely separate desktops and be able to move your mouse cursor between the two different desktops, so they're continuous. Just so happens we have here a card called Galea from France that allows us to work this way. The first thing you might notice between your RGB screen and your NTSC screen is in RGB, you quite often have a black border around your image. Computer monitors are under scan. They fit the whole image area inside the bezel so that you can see everything that's going on. NTSC and other video monitors are overscanned. Part of the image extends beyond the bezel. This is to take care of early problems with TVs with pictures shrinking, distortion of different picture tubes, etc. You can take good video monitors and put them in underscan mode, and now you can see your full image area and the black around it, but no one watches their TV this way, so you want to leave this button off. The problem with the overscan nature of video monitors is that any image on the very edges won't be visible to a viewer on a normal television set. So when you design your graphic images, you need to stay inset somewhat from your images. These are called safe areas. There's action safe area and title safe area. The difference between the bezel and the complete outside edge of your image is called action safe. It's about 5% in from the full image size. In a little bit from that is something called title safe. It's considered the safest outer reaches to put any text, because you might start getting some distortion here along the edges of your bezel. Now, virtually every video program and motion graphics program allows you to put an overlay on your composition, whatever video you're working on, so you can see where those overscan areas, action safe and title safe, land. You know to keep your graphics safely inside those areas. The second topic we need to discuss is the different color between video and your computer. If you looked at these two images, trust me, they're identical, but you'll see the colors really quite different between them. Your video monitor is typically a lot brighter than your computer monitor, and you'll see some of the details of the colors are a bit different between the two monitors. Again, video is in a different color space than computers. If you work strictly on a computer monitor, you can fool yourself as to what your colors are going to look like when you go out to a video monitor. This is another reason why we like to have a video monitor around. Now, just as a tip, not any television set is a great video monitor to check your colors on. Consumer TVs have a huge variation in brightness and color from manufacturer to manufacturer. We tend to get what's called production or broadcast monitors. They're the stuff actually used by real video professionals at television stations, etc. They're a little bit truer in color, and they're going to give you a better base reference. Now, let me close these images. I'm going to show you one more thing. I'll show you before I close. You notice the wheels on these bicycles? This one is fairly round. It has the perspective you would expect. This wheel, however, seems to be a bit shrunken in. Now, why is that going on? This is because not every pixel is created equal. So I close up my two images. I'm going to start with the basketball. And let me zoom in closely on it so you start seeing individual pixels. Pixels are blocks of individual colors that, when put together, make up your whole image. You'll notice on the computer RGB monitor, these blocks are square. However, in some video standards, they're not square. If I drag it over to my NTSC monitor, you'll now see that these blocks are taller than they are wide. This is because some video standards, such as the DV standard and what's technically called the 601 standard, a lot of people call it D1 standard for short, for NTSC video defines pixels that are taller than they are wide. The official ratio is that they're 10/11ths as wide as they are tall. Most motion graphics programs round this off to 90%. If you're working in PAL, it's actually the other direction. The pixels on video are displayed wider than they are tall. This is not because something's wrong, this is because it's just working in a different system. Maybe this illustration will show it to you better. It looks fine through my viewfinder, but as soon as I move it to my computer, it looks wider than I expect. The bezel's no longer round. This is because of the difference in pixel aspect ratios. Square in my computer, thinner than square in my DV camera. It's okay, because when I go back to a DV or 601 based system, it's going to look right again. Now let's take the other case. Let's say I started with an image on my computer. Here's another clock. Notice it looks round on my computer. However, when I take it out to a DV or D1 system with non-square pixels, suddenly it looks skinny. Neither system, square pixels or non-square pixels, is right or wrong. They're just different because the systems are different. And you're going to run into non-square pixels in other places than just NTSC video. There's a format of film called anamorphic, where the pixels you get are only half as wide as they're projected. Widescreen or 16:9 TV is another example where your pixels are going to look different on your computer screen and they're going to be finely projected when you get to video. The trick to all of this is knowing where you're coming from, what you're working on, and how you're going out again. Once you know that, you can track your pixel aspect ratios and make sure your job ends up looking right. Okay, that was all pretty abstract. Trish will show you how to actually track these things inside your computer while you're working.